Kansai International Airport was Japan's first full-scale international airport capable of 24-hour-a-day operation. It was constructed 5 kilometers off the Senshu coast in order to avoid noise problems. And now, work is underway to construct a second airport island that will expand the airport's functions in order to meet growing demand. Begun in July 1999, reclamation work for the second phase airport island is now in its final stage, with Reclamation 2 completed for the runway section and preparations underway for the new runway to begin operating in 2007. With an area of approximately 545 hectares, the second phase airport island is larger than the first phase island. On this second island will be constructed a 4,000-meter runway, taxiways, and other airport facilities. The second phase airport island is being constructed further offshore from the first phase island. So not only is the water deeper, the soft alluvial clay layer is also thicker, increasing the amount of potential subsidence. This made it necessary to conduct the work based on precise estimates of subsidence. The latest measurement technologies using GPS and echo sounding were employed for second phase construction to enable highly precise and efficient work management. The use of various kinds of state-of-the-art super heavy-duty construction equipment helped to shorten the construction time and reduce costs. Reclamation work for the second phase airport island began with emplacement of silk protection sheets, followed by sand spreading, ground improvement, seawall construction, and finally, land reclamation. Let's see how each of these steps was carried out. To prevent the turbidity caused by construction from spreading into the surrounding sea area, silk protection sheets were set in place around the work area. Ground improvement was carried out to quickly stabilize the 25-meter thick layer of soft alluvial clay on the seabed. A sand blanket was laid down to create escape routes into the sea for water displaced from the clay by the weight of the seawall and reclamation earth. Using sea sand, 9 large sand-spreading barges laid a uniform 1.5-meter thick layer of sand over an approximately 700-hectare area of seabed, a task that required about 1 year to complete. For the first time ever in Japan, large amounts of sea sand were imported from overseas and transported directly to the construction site. Ground improvement work centered on the sand drain method. In this method, sand piles are driven into the alluvial clay to create routes for the water contained in the clay to escape. The weight of the earth laid down on top of the clay then squeezes the water out, increasing the strength of the ground foundation. Using 8 large deep-sea sand drain barges, approximately 1,180,000 sand piles, each 40 centimeters in diameter and 25 meters long, were driven into the clay. Lined up end-to-end, they would extend approximately 30,000 kilometers, or about 3/4 of the Earth's circumference. A highly precise GPS guidance system was used to determine the positions of the sand drain barges and other work ships. After completion of the ground improvement work, construction began of the seawall for the airport island's outer periphery. First, rubble was set in place for the seawall's foundation. Then caissons were installed on the seaward side, which is most strongly affected by waves. The circumference of the second phase airport island is about 13 kilometers. About 90% is surrounded by a gently sloping rubble mound type seawall. First, sand fill and rubble stone are piled up in a gently sloping mound. Then the seaward face is covered with armor stones. Finally, wave dissipating blocks are installed in a highly stable construction. The top of the gently sloping rubble mound type seawall was leveled and concrete blocks were placed on top. To prevent the rubble stone from being washed away by waves, the seaward side was covered with armor stones, each weighing about 1 ton. Finally, the top was covered with concrete. Except for a section left open for subsequent construction work, the seawall was almost entirely complete by November 2001. Reclamation of the areas corresponding to the airport's basic facilities was performed first to stabilize those areas as soon as possible, specifically the runway and taxiways connecting to the first phase airport island. The earth used for landfill comes from 4 areas: Sumoto and Tsuna on Awaji Island, Kada in Wakayama Prefecture, and Misakicho in Osaka Prefecture. A single sand carrier can transport 3,000 cubic meters of earth, equivalent to 510-ton dump trucks. A GPS guidance system was used to direct each sand carrier to the precise position at which to discharge its load. Echo sounding was used to survey the contour of the seabed in order to accurately determine how the discharge landfill was accumulating underneath the water. The survey data was used to perform simulations that took water currents into account to direct the sand carriers where to discharge their loads. In May 2002, reclamation work using reclamation barges was begun. The reclamation barges transferred earth from sand carriers to the landfill site via belt conveyor. A GPS antenna on the end of the belt conveyor accurately monitored the conveyor's position as the work progressed. As subsidence began as soon as the reclamation earth was laid down, GPS surveys were used to maintain the designed reclamation height. In March 2003, the reclaimed section extending from the connecting taxiways and the runway section were joined, linking the second phase airport island runway section to the first phase airport island. In the area corresponding to the runway and the connecting taxiways, Reclamation 2 was begun to construct a uniform ground foundation of sufficient strength. In Reclamation 2, to ensure that rolling compaction would be effective, the earth was laid down in 60-centimeter layers, gradually building up to a height of 5 to 7 meters. The earth brought in by the sand carriers was transferred by 46-ton dump trucks and spread by bulldozers. Then, rolling compaction was carried out by heavy vibration rollers. The combined effect of the weight and vibration of the vibration rollers applied a force of 35 tons to create a uniform, solidly packed ground foundation. After rolling compaction was finished, the height of the reclamation was surveyed by a GPS vehicle. Detailed work management based on the survey results enabled creation of a uniform ground foundation well suited for use by the airport. In the runway section where Reclamation 2 had been completed, tests were conducted to determine the necessary runway thickness. Because a stronger foundation was constructed for the second phase airport island than for the first phase island, the runway surfacing can be made thinner. Constructing the underpasses, drainage pipes, and other below-ground structures on the second phase airport island at the same time as Reclamation 2 provided considerable cost savings. Underpasses were constructed to allow the roadways to pass beneath the taxiways connecting the first and second phase airport islands. Rather than dig tunnels for these roadways, the underpasses were designed with an open construction covered by PC deck plate bridges at points where planes would pass over. Compared to tunnel construction, this enabled the underpasses to have a narrower cross-section that could be constructed in less space, shortening the overall length. Such structures were constructed during reclamation to match the amount of subsidence based on highly precise subsidence estimates. In addition to significantly reducing costs and shortening construction time, this also helped to ensure safety. The utility culverts for the electrical and communications cables and the drainage pipes for quickly draining rainwater off the runway were also constructed during Reclamation 2, again reducing costs and shortening construction time. When the first areas of Reclamation 2 were finished, the reclamation work entered the final stage. Even while under construction, the second phase airport island has become a home for new life. Along the gently sloping rubble mound type seawall, concrete blocks on which seaweed can easily take root. Spore bags containing mature seaweed and other measures were used to create a seaweed bed as a habitat for fish and shellfish. To date, approximately 170 types of fish and shellfish have been observed. With its gravelly soil and salt air, the second phase airport island is a difficult environment in which to grow plants. Growing tests were conducted on turf grass suitable for large-scale planting, and also on wild plants found along the shores of Osaka Bay. During the second phase construction, tours of the construction site were given, including glass-bottom boat tours of the seaweed bed created along the seawall. It is now 6 years since the start of second phase construction, and the approaching completion of the second phase airport island will mark a major milestone toward the opening of the airport's new runway in 2007.